Hello, I'm Rebecca the Maths Lady, and welcome to this video which is all about teaching children about ratio. In this video I'm going to explain how we give children a really secure understanding of ratio by using paint or Play-Doh and then using the proportion bar. I'll explain how we go on to teach equivalent ratio, sharing amounts in a ratio, and using the size of one part of a ratio to calculate the size of the other part or the total amount. So if you don't need this video, here's your skip link to your next one, which is all about linear sequences. In order to deeply understand the teaching in this video, you and your children will need to have experienced finding fractions of amounts. So here's a link to the foundational video on that if you need it. And you'll also need to be fairly fluent with equivalent fractions and how they're represented on the proportion bar, because that structure flows on into the understanding of equivalent ratios. So here's a link to the video on that if you need it now. Okay, let's get started. Now, in order to develop a deep understanding of ratio, children are going to have to work on problems in practical contexts. And the most common mistake teachers make is to give children questions which use practical contexts, like mixing paint, for example, but the children have no experience of that in real life, and some of them aren't able to develop that understanding of what's going on in their head. So the great news is that this is a topic where you really need to get your hands dirty and get going with some art. And the best way to do this in practice in a classroom is with mixing colours, which could be Play-Doh, got red and yellow there, or paints. Got some squeezy bottles of paints. So I would start teaching this topic with some maths in the second part of a morning, and then I would extend it all afternoon into a huge, messy, creative art session. So I love working with Play-Doh. Some of you might have seen me at conferences doing sessions on all the sorts of maths you can teach with Play-Doh. It is the most wonderful way to learn. Of course, you can make your own, just add plenty of dye for this mixing purpose and plan it in advance to make sure it's going to work with the particular type of Play-Doh you're making. So first of all, children need to think about what colour we're going to get if we mix red and yellow. Hopefully some of them may have a sense that it's orange. You can discuss that. You may want to do some colour mixing in art first so they can explore these ideas before the lesson. And when I'm making orange, I find that the red dominates, so I don't want quite so much of it when I'm making orange, or the orange will be very nearly red. In my recipe, I'm going to use 3 teaspoonfuls, I've got a measure set here, of the yellow Play-Doh and 1 teaspoonful of the red Play-Doh. And of course you could do this with paint, just pouring the paint into the teaspoon. So here's how we do it. I've got my red Play-Doh here, just going to break off a bit and then estimate just a bit more than a teaspoon, put it onto a flat surface and use my teaspoon to squash out a teaspoonful like that, and I will get rid of all the bits I don't need. That's 1 teaspoonful of red Play-Doh. Now I'm going to measure out 3 teaspoons of yellow Play-Doh in the same way. And when I've done that, it will look something like this. And then, of course, we get the fun bit where we squish it all together to make our orange. And the kids will be fighting for this opportunity because it's just so nice. You just squish, 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 get a lovely marble effect at first. See a little bit of that, marbling. Eventually, and it doesn't take too long, maybe just about a minute of squishing and folding in, you get a lovely even orange colour. Light's catching that, but it is beautifully even. And there's that orange in between its original parent colours. And of course, you could have done that with red and yellow paint, measured in the teaspoons in the same way, if you've got 3 small pots for mixing your paint. But the thing about being a designer is that you've got to be able to reproduce your recipe. It's no good if you just make that and you know it's beautiful and you like it, but you've not got a recipe for making it again. So we need to think about recipes. Our recipe here was 3 teaspoons of yellow and 1 teaspoonful of red. So we could make this much Play-Doh again. But what about if we wanted to make more orange Play-Doh than this? Could you use 3 whole pots of yellow Play-Doh and 1 whole pot of red Play-Doh? Would that work? We do not need perfect answers at this stage of exploring this topic. We just need children who are switched on and thinking for themselves and are deeply involved in the maths work that they're doing. If we're still in the morning lesson here and it's not the case yet that all the children are getting their hands dirty making their own shades of paint, then I would share some different recipes with the children. Maybe like this. Remember, our original recipe was 3 teaspoons of yellow, 1 teaspoon of red Play-Doh. And ask them which of these recipes would give you the same shade of orange, which would give a lighter shade, a more yellowy shade, and which would give a darker shade, a redder shade. And let them work on those questions in their groups and see if they can puzzle out some answers. And you'll find that some of the children can reason really well already and are really confident about their answers. Others aren't so confident and are making mistakes. And you can actually make these recipes to check, and you can compare them to check the answers people have come up with, which is a great way of bringing the whole class back together. And then for your long afternoon art activity, you want to give every pair of children or small group of children 2 colours of paint or Play-Doh that they can mix, and ask them to develop their own set of shades with their own recipes. And here's an example of a set of colours that some students I was working with created by mixing blue and yellow Play-Doh. And as you go around and talk to them individually, talk to them about the different ways in which they could describe their recipes. Begin to introduce the idea of ratio being counting the number of parts of one colour and comparing it with the number of parts of another colour, and fractions. So in our original recipe we were 3 parts yellow to 1 part red, and 3 parts yellow to 1 part red is a ratio recipe that you can scale up. But you could also say that recipe is 3/4 yellow. 3/4 of the Play-Doh in here is yellow and 1/4 red. It's really powerful at this stage to connect those ideas of describing recipes either through fractions of the total or through ratios where you're comparing one proportion directly with another proportion without thinking about the total. But all this work is very informal at this stage. We'll come back the next day into a lesson where we're going to make sense of it all. So in your second session with your students, you want to start to formalise all this very fluid investigational work, and you need to start drawing some proportion bars to show your ratio. Here's a proportion bar to show the original recipe of 3 teaspoons of yellow Play-Doh to 1 teaspoon of red. And by discussing this, we can very clearly show that this is a 3 parts to 1 part recipe. The ratio is a clear way of explaining the recipe. But it's also fine to say that this recipe is 3/4 yellow and 1/4 red. Ratios and fractions both show proportion. With fractions, we're connecting the size of one part to the size of the whole. With ratios, we're talking about the relationship between the sizes of the different parts. So then you can set up proportion bars to clearly show all these recipes that we looked at in the previous session and compare them precisely. And now it's easy to see that it was the bottom recipe, 30 millilitres of yellow to 10 millilitres of red, that gave the same colour of orange exactly. And we can see which of the recipes gave a darker shade and which gave a lighter shade. So if we just take the 2 recipes that were the same and compare them, we start to see that the topics of equivalent ratios and equivalent fractions are linked. The visual imagery for equivalent ratios and equivalent fractions is exactly the same. And just as we could multiply the tops and bottoms, the numerators and denominators of a fraction, by the same amount because we're splitting them into the same number of parts and create an equivalent fraction, we can do exactly the same with a ratio. If we multiply both sides of the ratio by the same amount, we create an equivalent ratio. You can also think of equivalent ratios as being where the second number in the ratio is the same multiple of the first number. Let's just dive into that a bit more. So we had the ratio 3 to 1, and we can multiply both sides by the same number to give the ratio 6 to 2 is going to be the same ratio. Effectively what we've done, ratio 3 to 1, which is the change there, we've just cut every bit in half. We've got the ratio 6 to 2, same ratio. But while some people think about multiplying that by 2, therefore we multiply this by 2, not all people see it that way. Some people are saying that number's 3 times as large as that, so this number must be 3 times as large as that. So they're calculating either left to right or right to left rather than top to bottom. Both methods work, both are fine. I use whichever one's easier depending on the numbers. Sometimes one's easier, sometimes the other is easier. So for example, if a question was asking me to find the equivalent ratio of 4 to 12 when this number is 6, I might not feel comfortable multiplying by 1.5, but I've noticed that that way I'm multiplying by 3, and I can do that, so that's 6 to 18. But if I had felt comfortable multiplying by 1.5, that would have worked as well. So when all that is securely established, now you need to start working on problems where you're sharing an amount in a given ratio. If I'm trying to make 800 millilitres of my orange Play-Doh, and the ratio of yellow Play-Doh to red Play-Doh was 3 to 1, yellow to red, how much of each colour Play-Doh do I need? The key here is to get children drawing a quick proportion bar. It is 3 shares to 1 share, like that. And they're going to have to share their 800 millilitres into 4 equal parts. They can see that. With a bit of thought, they should get 200 millilitres in each part. This is yellow, that's red, and they know that their answer is 600 millilitres of yellow and 200 millilitres of red Play-Doh. These videos are targeted at children aged 9 to 11. Children at that age do not need an abstract method beyond drawing proportion bars by drawing blocks for each share. This method will get them through. It's really reliable, it's easy to remember. As soon as you start teaching them methods where you divide by the total number of parts and multiply by that, they're going to go wrong when you move on to a slightly different type of problem where they don't do that. For example, we might have said, I've got 900 millilitres of yellow Play-Doh. How much red Play-Doh should I have added? So there, the problem has changed. It's now 900 millilitres of yellow, and we want to know how much red. I'm just going to rub out these numbers. It's the same block diagram because we're sticking with the same ratio for that orange Play-Doh recipe. So the 900 millilitres of yellow is 3 parts. So there must be 300 millilitres in each part. All the parts must be the same size. So the answer is that we need 300 millilitres of red Play-Doh to make up that recipe. And we could also have asked the question, how much orange Play-Doh will that produce? And we can work out that it's 1200 millilitres of orange Play-Doh. So there are 3 types of question there. Sharing a total amount in a ratio into parts, finding one part from another part, and finding the total when you're given one part. And as long as you draw block diagrams that look like a proportion bar, which is really easy to train children to do, and really powerful because it's connecting up their maths. It's making all the right links to their other areas of maths and knitting together their understanding of what's going on. They are going to be fine. Your extension work at this stage, I would extend this into art and design and doing deeper work on developing their palette of colours and explaining the recipes. Now they've done more precise work on the deep understanding of ratio, they should be able to go back to that experimentation phase and do some really powerful recipe development work where they express their recipes in ratios. So your takeaways from this video are that you need to teach ratio really practically with Play-Doh or with paint. Let children experiment and then translate the work they've done into representations on the proportion bar. And you can see, as I did there, you can change the colours on your proportion bar to reflect the colours they've been working with. Explore different recipes, and then as you start to work on ratio problems, make sure the children are drawing block diagrams as proportion bars to show the equal shares within the ratio, so they deeply understand what's going on. And there's no need to introduce abstract methods like add up the total number of parts, divide your amount by that number, and then multiply by the numbers in the ratio. It's too abstract. Keep them working with the blocks until they can clearly come up with those methods for themselves because they so deeply understand what they're doing. Most of all, have fun. This is a great topic that you and the children you're working with should really enjoy. I hope you enjoyed this video. If you did, I hope you'll join me for a few more and maybe give it a like or a subscribe and share it with your friends. If you want to see the list of free videos that are available, they're at authenticmaths.co.uk/videos. And we haven't quite got there yet, but hopefully there will be some videos on ratio at some stage in the non too distant future, as it looks like my fabulous worksheet creator, Jeff, is staying locked down in Spain just for now. Sorry, Jeff, but hopefully we'll get some more great worksheets out of it. If you have any questions, please post them in the comments, or any thoughts. Hope you'll join me for the next video soon, which is all about linear sequences. Take care. Bye for now.